Hello everyone, this is Dr. Ian. For today, we're going to be talking about how to predict outcome using linear regression. This is one of my favorite topics in statistics because this is when statistics becomes a little bit more applicable to our research or in actual data that we can collect in our classroom or outside our classroom. So most of the time I use this to introduce project in statistics, and for most students, this is when they can really apply some complex mathematical calculation in their real life application. So for students who are working with their statistics homework on linear regression, we have videos that you can watch in the description box below. And for teachers, you can use our lessons and this technique that I'm using when you are working on helping your students understand the exciting and valuable lesson on linear regression. So, of course, the first thing that we need to share is, of course, how correlation or the correlation coefficient or the R value is interpreted when we are using technology or our graphing calculator or our Excel. So it's not enough that we're able to produce our statistic correctly. We need to make sure that we are also understanding the reason or the interpretation of these values. So we know that R is the numerical descriptor for the strength and direction of our two quantitative data sets, or the association between two quantitative data sets that we are collecting. And it's important that we know how to interpret it before we use the app that I'm going to show you in just a little while. And of course, our predictor or our our model, or also known as the LSRL, or least squares regression line, or basically the model or the formula that we use to predict an outcome given the value of X. So two quantitative data set that you can play with and you can use for your statistical project could be the number of hours you sleep and your statistics grade in class. So in this particular case, you can collect data and ask your classmates and friends how long they sleep and their current grade in statistics. And in this case, using an LSRL, we'll be able to predict your future statistics grade based on the number of hours that you sleep at night. So that is how exciting this topic on LSRL is, and understanding your formula for predicting an outcome, also known as the LSRL. Y hat is equal to A plus BX, where A is our y-intercept and B is our slope. And that is what we're going to be working on today. So there are several partnership that you can work with as your project. So when I say partnership, so you can pair two quantitative data sets. It could be, let's say, how fast you run and your weight, and we'll be able to predict how fast you're going to run based on your weight in pounds using linear regression. Or you can also use this as how many pets you have at home and how much money you get from your parents for your allowance weekly. We can also do a linear regression analysis for that. And for our example for today, this is what we're going to be working on: predicting your height by giving us your shoe size. So we'll be able to produce a model or a formula that can predict your height by just asking what your shoe size is. So we need to produce our linear regression model, y hat is equal to A plus bx, and we also need to produce this basic linear regression statistic, which is the slope, the y-intercept, the value of the r, and the value of r squared, and you need to know how to interpret all of these values. So let's work on this app that I love to use in my calculus algebra and trigonometry classes. And in statistics, specifically on linear regression, we can use this to write our linear regression model. So how are we going to do that? So we have the x, or the input, and y as our output, which is our response variable and explanatory variable. And in this case, our explanatory, or our independent, will be your shoe size, and your y sub 1, or your response variable, would be your height, or your dependent variable. So let's say we ask someone their height, and their height is, let's say, 5'6", and 5'6" in inches is 66 inches, and their shoe size is, let's say, 9.5. So 9.5 is their input, our input, or our independent, and our output, or dependent, is going to be the height. And in this case, it's 66 inches because you're 5'6". And then if we are going to collect or write our formula, it's not enough to just use one sample. We need to have more sample as possible, and that's what we're going to do. So let's just say that, let's fill this in. Let's say the next person has a shoe size of 9 and height of 67 inches, or 5'7", and the other person, let's say, is 8 and his height is 65 inches. Let's say 7.5, and let's say the height is at 62. And another shoe size, let's say it's 10, and the height is, let's say, 70 inches. Let's say it's 9.5 and the height is 65 inches. And let's add another one. Let's say the shoe size is 8.5 and the height is 62. So we now have our data, and you are seeing the scatter plot right here. So this is the scatter plot. So this will determine if your strength is weak or strong, depending on the value of your numerical summary, which is right here at the bottom. So now we know that we have our r squared, or our coefficient of determination, our r, or correlation coefficient, our m, which is the slope, and b, which is the y-intercept. So let's write it down. So the slope is m, 2.43. 2.43. Y-intercept is 43.79. 43.79. Correlation coefficient is R, 0.78. 0.78. And the R squared, or coefficient of determination, is 0.60. 0.60. So now that we have our data here, and the scatter plot is what you are seeing right here, now let's go back to our board right here. And now that we have our statistic, now we can write our predictor, or LSRL, or our linear regression. So now that we have our y hat is equal to a plus bx, we'll be able to plug in the value of the slope and the y-intercept. So we have y hat is equal to a, which is the constant, and the constant is your y-intercept, 43.79, plus b, which is your slope, 2.43, and your variable x. And if you want to make this more descriptive, we can say that y hat is our predicted height, and it's equal to 43.79 plus 2.43x, and the x is our shoe size. So this is now our predictor. So you can see that this is our model that we are going to be using, so we can predict someone's height by asking their shoe size. So this is how statistics is pretty powerful and pretty exciting, especially when we're creating project like this, because now we're using mathematics to predict an outcome, and using mathematics as an applied science using linear regression. And now that we have our summary, we know that the correlation is 0.78, which means the association between the data that we have collected is quite strong at 78, or 0.78, and it's positive, which means when your shoe size is increasing, your height is or your predicted height is also increasing. And we have our R squared, or coefficient of determination, which is 0.6, which is also pretty high, which means 60% of the association based on our linear regression is accounted for by the given value of our x, which you will learn in your lesson on your linear regression. And that is just how we use some application that will help us calculate our values more efficiently and correctly, because we know that we can use our formula by hand, but using the formula by hand without the use of an application or calculator, it's like trying to figure out a virus using a magnifying glass when you need is an electron microscope. And in this case, your electron microscope is your Desmos, so that it will give you a more accurate outcome that you are hoping for or calculating based on your statistics. So two things: you need to know how to produce your numerical summary using our application, and the application is just there to help us produce the numbers, but we need to make sure that we are also understanding and knowing how to interpret our statistic based on our calculated statistics. And for teachers who are also excited on teaching linear regression, share us how you're teaching lesson like this to your students and the apps that you are using. And for our students, what are your apps, or what are the methods that you are using to calculate your statistic correctly, and how do you remember how to interpret all of these values that we are calculating? You can also comment it down below. And of course, if you need to master your skill on linear regression, we have videos down below that you can use. And again, this is Dr. E, and see you again next time. Bye!